How to fix a wing mirror, or more specifically how to fix a bodged repair on a wing mirror. So this wing mirror has gone a bit floppy. Look at the state of this repair. Somebody's got a screw through it, some contacts adhesive on it, rather than try and fix it properly. And it's the same the other side, so let's do it properly. Remove the screws, dismantle the wing mirror, and try and fix the floppiness of it and make sure that the electric motors work. And before I go into details of how you dismantle and fix your wing mirror, I've already fixed the right hand one. You see now it's nice and firm and stiff. I've covered the plastic, also tightened it up with same solution I use on the plastic bumpers. See my other video on a surprisingly good way to bring plastic back to life, looking black again. Removed all the glue, and the electric motor for moving the wing mirror in now works as well, which we can show. Not every model has this option, but when you put the mirror adjusting switch in the central position, see this little sign here which indicates that the mirrors will come in. Push that button down and you see now the mirrors dip in, which they didn't do before, of course. So what was the problem on this mirror? Why was it all floppy? Well, what happened is the motor had stopped. This is the sort of motor that they use inside them. It's a standard size, the same sort of size motor they use on door locks, and it got less and less powerful, and it hadn't fully locked in its fixed position, this firm position, and being in a halfway position it was all floppy. So you can take it apart. You can get these sort of motors on eBay, near enough the same size, not exactly. This was the actual old one that I removed. In the end, because of the difficulty in removing the worm gear from the end of the shaft, I just swapped the brushes, the end part, because the fault with these was this little square object here, which is a little, surprisingly, is actually an electronic component like a thermistor, and that little square rectangular plate was pushed down in between these two top pieces of metal, which you can see are joined at the moment. It's just where my fingernail is there, and that is in series with a connection to the brush. And what that does is allows a reasonable amount of current to initially go through it, and then as it warms up, the resistance of that thermistor increases, lowers the current, sort of current limiting device. The new motors that you get don't have that in, and one solution is basically just to short it out, which means the motor will be powerful all the time. It's not too much of a problem because the motor is only on for a few seconds or so, so it has a very little chance of overheating. So you could just short it out, take that plate out and join those pieces of metal with a soldering iron, bit of solder. As I say, I swapped the end piece mainly because I'd accidentally knocked off the carbon brush of one of the arms, so I couldn't use this piece again. On new motors, this plastic end piece, near enough the same size. This circular bit is about the same size, just a little fraction thicker. It's created a little bit of a problem in fitting it. Had to grind a little bit off the shaft, but nonetheless we managed to fix it. One works okay now, nice and firm. And now we'll go through showing you how we dismantle and fix the wing mirror by looking at the other one. So this is the left hand mirror, old grey colour still. Taking the screw out and you can see it's all floppy, non-locked. Slightly different fault I think on this one, because you can hear the motor working but some gears are slipping, so it may be another problem. Let's see. So to remove the wing mirror, first you've got to remove this plastic panel. You see here there's just clips at the bottom that go in like that, and then it's held in at the top by this plastic stud that goes in that hole. These normally snap off, and as you can see here I've re-glued it, which you'll probably have to do unless you can get a tool in the side there and just lever it off without ending up snapping the stud. After you remove the plastic, then there's these Torx headed, or recessed Torx headed screws, 3 there. These wires obviously need to be pulled out. These 2 wires are the ones that control the motor for going in and out. This one is the angle of the mirror control, which I don't think we have too much of a problem with. It needs a firm 2-handed pull to get this one disconnected. There's also a little screw here, fillet screw or posi drive, needs undoing. Once you've got these 3 bolts off and that screw, the whole wing mirror will then lift away. And the bit you require for those Torx headed bolts is a T30, or if you want the chromium versions, CRV T30. I'd recommend you get yourself a screwdriver bit set with a screwdriver. I'll put some links in on the video description. Useful for taking all sorts of things apart and not too expensive. Then we've got to disconnect this little piece of plastic, which is just a push fit into there, and then all this rubber stuff can peel off the main mirror. Some of it may be split, but don't worry too much about that. There we go, that's reasonably in one piece. This bolt snapped while I was removing it, so later on I'll have to drill that out and get a new bolt. And then you can see here we've got the wires going through, but they're actually glued in place. The glue is not too strong, and what we can do is just prise it out, so here and in here. And also we remove this plate, which you need a screwdriver for. Just get in there and pull it up, and then some more Torx screws need undoing. This disconnects the outer plate from the mirror part. Basically the two are connected together by a motor gearbox assembly, which is where the fault lies, which is why it's all floppy. See, 2 of the wires come through this section and come through, I think come through here. So to get these glued wires released, dig a screwdriver down and prise it away from the edge of the plastic. You may be able to get out in one lump, possibly 2. Here she comes. There's also a piece of foam in there as well, underneath the plastic. There we go. These ones are well glued in, but that's those released from the glue, and that's that one. And now we'll be able to feed the wires through the hole and release it from the outside piece. Use a T10 Torx bit to undo these 4 screws. Should be able to then pull out pieces of foam, go along the way and bring the wire out. So with this disconnected, what we do need to dismantle is this motor section. This is the motor that connects a piece of plastic that goes to the bodywork to the wing mirror, and you can see this is the bit that's all floppy. So we need our Torx T10 screwdriver bit again. Disconnect the motor. These Torx screws need to be taken out, and the whole thing will lift out. So with those screws removed, the motor mechanism lifts out. So, and these are the 2 halves that normally rotate. That can be removed, these 3 screws on the end. Not a lot of point in doing so though. The main part of the mechanism is in this body here. So again, 4 screws need removing, and then we'll reveal the motor and all the gears. As we can now see, gently take this apart. There's the electric motor, there's some of the gearing. This motor drives this little cog here. That should sit flat and in the middle like so. This little notch here lines up with this arm, so don't worry too much about the orientation, only goes back one way. This motor lifts off, revealing the gears. So this gear can lift out also. Can't see too much wrong with the gears at the moment. So this motor will remove by just getting pushed out. These contacts pull out like so, check which way around they go. Blue on the top, and then the electric motor should just push down like so, and that comes out. There we go. To take these apart, you need a small precision screwdriver, and you need to get it under that tab on the side, lever it up to bend the metal out. Often a little bit tricky, but just about possible, like so. And you can see the ends partially released there. Do the same the other side, then you'll be able to remove the plastic section, which is the bit that contains the brushes and that thermistor I mentioned earlier. The tricky thing with getting the plastic on and off is to make sure that the brushes come over the what's called the commutator part or the end of the motor. There's a little washer on it, so you might have to give it a little bit of a wiggle. Might just see down there where the brushes are. Sometimes you just have to push them from side to side to enable you to either fit them or release them. In this case, release them from that washer that's on the end. See that that washer there, and here are the brushes that have to go either side of them. So when you're refitting, you basically have to sort of push them apart to get it over that washer. That's the only real tricky thing. Here's the fitment of that little, I think it's the thermistor, which can get too resistive. So what we'll do is get a multimeter, check the resistance of that, and see how that is performing. As I say, the motor was operating, but for some reason gears seem to be slipping. So we need to check all these gears carefully. Haven't seen any fault yet, so let's continue. Yep. So this is a connection that goes into the wiring, goes onto this piece of metal, through the thermistor, out through this piece of metal onto the brush. So let's measure the resistance of this thermistor. On the other motor that wasn't doing very well at all, wasn't working, the resistance of this thermistor was around about 20 ohms or so, which was no good for getting the motor to work strong enough. This one, the resistance you can see on the meter is about 1 ohm. Yep, 0.9. In fact, if I short the probes together, probably just under half an ohm already. So 0.4 of an ohm, 0.9 on there, 0.8. So we've got about roughly half an ohm of resistance in the thermistor. So this one is good, whereas the thermistor from the old motor, which is here, we can measure this again, and we'll see the resistance in this case, because it's quite cold, is about 11 ohms. So that is a sign of the thermistor being no good. So as we've seen already, the motor was actually operating, so I think that is a good enough motor. But one thing I like to do on motors is clean up the copper commutator, this bit on the end, which makes contacts to the coils. It's called the commutator. So we'll just pull off the washer and get a little bit of fine sandpaper, something like 2400 grit grade, and then we'll just rotate it round to clean up that copper, because the copper gets oxidized over time and gets a bit resistive. So it's always a good idea to do that until it gets nice and shiny, like so. Wipe off any grit that might have got on it as well. So there's not much we need to do to this motor. If it does operate, we'll check that as well in a minute. We just need to reassemble it, get the shaft in, get a tiny little screwdriver, and as you're pushing on the end, as I said earlier, you just need to push those brushes so that they go over the washer on the end of the commutator, otherwise they're not going to make correct contact with the motor. There we go. Check it rotates okay, which it does. And then just re-bend the pieces of metal over onto the plastic. You might want to put it on the ground, give it a little tap with a hammer or something. Actually that doesn't look too bad. I think we'll just push that one in. If you do decide it needs a new motor, or you want to change the brushes, you can get these pretty identical motors on eBay direct from China for about £1 each. I got 5 for a fiver, £5. Pretty much the same. That end piece, yep, near enough the same. A fraction, maybe a fraction deeper, maybe not. Thought it was. Yeah, maybe just that plastic's a little bit longer, but pretty much the same size motor. The only problem, of course, is they don't have this worm gear on the end, which are pressed on. Quite difficult to shift to get off, probably if you heated it a lot. You get that one off and push it back on there. Obviously you have to chop the shaft down, more trouble than it's worth. And on the other wing mirror, I just changed over the brush construct. Slightly different mouldings around this area you can see here, so I'd cut away a little bit of the metal by grinding it off, but it was then possible to get that new brush structure onto the end of the old motor, which brought it back into life. So to test the motor, we need to apply 12 volts onto our motor. The new motor came with these little tags, which I'm just going to use to push in the old motor, or you could use the original wiring. So to test it, I've just got a couple of wires from a power supply. You could also do it from a battery, which is 12 volts. Connect it onto your connections, just check the motor spins. I always like to feel how strong the motor is going as well, just by seeing if I can hold it with my fingers, and that resists nicely, turns no matter how I hold it, so that's a good motor. So then what we'll do is try and reassembling it and see if we can work out what the problem is. Again, on eBay there's a little kit of parts that comes with all of the replacement gears. As I say, I can't see too much of a problem with these, so let's just try and see, I guess. Also the motor has to go back in its housing, and reassembling it. And then what we'll do is test the whole motor construct first. So while reassembling it, make sure that the axes or the gears correctly go in the holes. That's a bit too sloppy, so something is not quite right there. Maybe that's why the gears are slipping. It's not quite tight enough there. Motor being a little bit loose in its housing, so what we'll do is just jam a little bit of something down the side, a bit of plastic or something, stop them moving, which I'm sure will help. So that's better. What I ended up jamming down there was the old thermistor from the other motor, plus a bit of the glue that we removed earlier. It's a bit stronger. Let's try that again. That is a bit better, a bit firmer. And there's two other possible causes for why the gears were slipping. One of the main problems on this one was the other side of this alloy housing are two little studs, and you can see where these little stand-out positions are, where they actually sit on this housing. This side was broken off, so you can see here what I've done is to put in a little roll pin to replace that stud. So I drilled through where the stud sits on this part of the housing. See, I've just ground off the top of it, just let it come through a little bit the other side, and that holds it a lot firmer than what it was previously. Previously there was a little bit of extra movement there, which is probably why the gears were slipping. The other possible cause is maybe the teeth of these gears were a little bit worn off, and there's two possible fittings for this part. So if you take the end off by the 3 screws, you see this is symmetrical by 180 degrees, fits in the end there. So if it was fitting that way, you can just rotate it. You see this only rotates by about 1/4 of a degree. So by rotating the whole thing 180 degrees, then a whole new set of fresh gears will get engaged and used. What you will find is ultimately this will be 180 degrees out as well, so the wires will be on the other side. Hopefully they should stretch, but you can see this is symmetrical, so that should be possible to still connect that in with that 180 degrees out. These gears aren't too bad, so probably doesn't matter either way. On this particular one, the main problem just being the stud. So let's reassemble it and test it again. On my first trial reassembly, the gears did slip one way and not the other. Now we put that extra stud in. Let's try that again. You'll see I have to grind down that rolled pin that I inserted to get it to not foul against the gear as it's inserted, but that's not a problem. Just used a cheap little grinding tool. Okay, so now we've got it all reassembled. We'll just test our motor again. Let's go. Good one way, no gear slipping, nice and quiet. And good the other way, no gear slipping. Test it again. That's all good. Now we can start more reassembly. Right, that's the mirror reassembled. Time to put it back on the car and test it. So put glue in around the wires where it was previously, and the piece of foam back in. Clip back on there. That's it reattached. Let's just test it out before putting it on the side panel. There we go. All fixed, working well, no slipping gears. Nice and firm, not floppy anymore. Needs a bit of colouring black like the other one. Same with this side, nice and firm, all the glue taken off. And the screw hole also filled up with a bit of polymer sealant. Okay, good luck with yours. Thanks for watching. Bye.